All right, so continuing on, of course, the most obvious mechanical barrier, that means the physical barrier to you and the outside world, right? The skin, of course, is the biggest barrier and the largest organ of the body that will present a mechanical barrier. The other one is mucous membranes. Mucous membranes are going to be consistent in the columnar ciliated epithelium with goblet cells. So we're going way back to your understanding and histology of the uh, uh, the system in the sinuses that produce mucus, and that mucus is presented onto ciliated epithelial cells, and that is a physical barrier. Anything you breathe in, that you inhale, that you eat, uh, your immune system via these mucus producing ciliated epithelium, they get to take that stuff out. Now, that's not always enough of a barrier, but it's the first line of defense. It's a very, very important first line of defense. And that's what we call it, the first line of defense there. Right. So anything that is all non-specific, and this doesn't, when we say non-specific, we're saying whatever comes into your body that is a foreign, hostile invader, and your body doesn't know what's foreign and hostile at first. It just wants to take it out. It doesn't want it to penetrate into the deeper, the inner sanctum, so to speak, of your body. So here we are, epidermis sloughs off. That removes superficial bacteria, right? You do that every time you take a shower or a bath, or anytime you scratch your skin. There's going to be bacteria present on the superficial skin. Ciliated epithelium, respiratory tract sweeps away pathogens. We've already talked about that. Hair traps pathogens. That's why you wash your hair. Tears, saliva, and urine wash away microorganisms. Extremely important processes to get that stuff out of you. Of course, you know that sometimes this stuff does get in. Once it gets inside your skin, the mechanical barriers, you've got chemical barriers. Chemical barriers include enzymes. You've got some examples there, right? You've got pepsin in your gastric juice that's produced by your uh, whoopsie. Oh, shoot. I hit the wrong button there. Pepsin is produced by your pancreas, and lysozymes are in tears to destroy microorganisms. There's interferons that are produced by cells that circulate through your cardiovascular system. They block viral replication, act against the growth of tumors, stimulate phagocytosis. Defensins, as I mentioned before, peptides. Peptides, remember, are small chains of amino acids that are produced by neutrophils and other granulocytes. They cripple microbes. Collectins are proteins that protect against many bacteria, yeast, and viruses. Complement is a group of proteins. There's a whole bunch of proteins that are known as complement. They're in the plasma. They're circulating around in your bloodstream. They stimulate inflammation. They attract phagocytes and they enhance phagocytosis. My favorite cell in the body, natural killer cells. NK cells are a small population of lymphocytes. So you know that lymphocytes, remember the acronym, never let monkeys eat bananas. So the never is neutrophils. The L, never let, those are lymphocytes. Those are the second most populous type of white blood cell, lymphocytes. Okay. NK cells are a subpopulation of lymphocytes. They're different than B cells and T cells, which are also lymphocytes. Those are part of the adaptive immune system. We'll get to that later. They defend against viruses and cancer cells by secreting cytolytic. Cytolytic means cell destroying or cell lysing. This process called cell lysing means that the cell is destroyed. The outer membrane is destroyed. Those substances that do that, they're proteins. They're called perforins. They lyse the cell membrane. And NK cells also enhance inflammation. And that's an important, inflammation is a funny double-edged sword in this process. You need to have a good inflammatory system. You need to have an inflammatory response, but you don't want to be too overly aggressive with that response. So here's the chart. As you know, we have those charts. Inflammation produces local redness, swelling, heat, pain. You know what inflammation is. You've seen it before. You've twisted an ankle. You have had some sort of damage to your epithelium. You fell down on the driveway while you were rollerblading or whatever. There's redness, there's swelling, there's heat, there's pain. Right? It's a process. In this process, your body walls off that infection and inhibits the spread of that infection. Right, so blood vessels dilate, capillary permeability increases, fluid leaks into tissue spaces. That is what inflammation is. Right? The tissues, the result there. Tissues become red, swollen, warm, painful. White blood cells invade because you've broken blood vessels. Of course, there's going to be red blood cells in there, but there's going to be a lot of white blood cells in there too. Their job is to figure out what should I get rid of. So pus forms as white blood cells and bacterial cells and cellular debris accumulate. That's the pus is the degenerated bodies of white blood cells, if you will. Tissue fluids accumulate, clotting factors seep into the area, of course. Clot containing threads of fibrin. Remember, that comes from fibrinogen that's floating around your bloodstream. That may form if it needs to. Fibroblasts arrive. Connective tissue sac may form around the injured tissues. Phagocytes are active. Bacteria, dead cells, other debris are removed. Well, of course, they need to be removed. Cells divide. Newly formed cells replace the injured ones. If that's the epithelium, so be it. If it's muscle tissue, so be it. Whatever needs to be replaced is replaced. So this is the order of activation of all of these structures, all of these tissues in an inflammatory response. Again, here's innate defenses, phagocytosis. That just simply means the removal of foreign particles from the lymph. Phagocytes in blood vessels and tissues of the spleen, liver, bone marrow remove particles from the blood. Hopefully they're foreign invading particles. The cells that do this, as I said, neutrophils, macrophages, they're the most important ones. Here we go. Neutrophils and monocytes. Monocytes are circulating in the blood cells. When they enter into the interstitial tissues, they become a cell called a macrophage. There you go. Monocytes that leave the blood become macrophages, which can be free or fixed in tissues. Mononuclear phagocytic system, the reticuloendothelium, consists of monocytes and macrophages of the body. Those are the things that will take up those foreign invaders. A fever. So you know what a fever is. You've had a fever. Everybody's had a fever. Fever begins when a viral or bacterial infection stimulates lymphocytes to proliferate. Those lymphocytes secrete a substance called interleukin-1 or IL-1. That's an important protein that's produced. IL-1 raises the thermoregulatory set point. So it goes to the hypothalamus and it tells the hypothalamus, let's kick it up, raise that set point. And so the hypothalamus obliges. IL-1 is called an endogenous pyrogen. Pyrogen, right? Pyrogen, if something is pyrogenic, it will increase your body temperature. There are drugs, the most common of which is ibuprofen. Ibuprofen is an anti-pyrogen. It will lower your body temperature. That's not to say that you want to lower your body temperature. Your body is raising its own set point temperature because that will help to fight viruses and bacteria from multiplying. So you don't always want to inhibit that. Elevated body temperature indirectly inhibits microbial growth or virus growth, causes the liver and spleen to take up iron, making it unavailable for bacteria and fungi to use. So yes, bacteria and fungi would like to have access to that iron. They don't bring it in with them. They use your body. They take the stuff inside your body to make them reproduce, to make them make more copies of themselves. Your body wants to prevent that. So that's one of the ways in how it does it. High body temperature also increases phagocytic activity. As I told you, those phagocytes, those cells that want to devour the bacteria and viruses, they're enhanced by a higher body temperature. Now, once we have all that, now we get to the what are known as adaptive or specific defenses. And I'm going to stop this video and we're going to move on to that process. Whoopsie. Yeah, see, I don't know how this works just yet.